Welcome to the about 10th time that I've tried filming lesson 7.6 for Math 9. Let's see if it works. Dun, dun, dun. Oh my goodness. It's working. It's working. It's a miracle, people. Today what we're going to learn is we're going to learn about lines of symmetry. How exciting. So if you remember, this unit in Unit 7 has been all about shapes. We've been making shapes bigger, making shapes smaller. We've been moving shapes. We've been reflecting shapes. Now today we're going to talk about lines of symmetry, which essentially is cutting shapes in half. And when we cut them in half, we have to cut them perfectly in half so that the two sides are the exact same. They look the same. Not that they have the same amount, but that they look identical. So if you look at this beautiful picture to the right, I have what looks like a stoplight, probably green, yellow, red lights. You notice that they put a dotted line right down the middle right here. Doot, 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 doot. That would be me cutting the line perfectly in half so that the left side is identical or equals the right side. It's identical. Awesome. That is called a line of symmetry. So this thing right here, that is a line of symmetry. Now, knowing a line of symmetry is good, but knowing what isn't a line of symmetry is also important. So sometimes people think that it just means you're cutting something in half, and they would look at this picture and they would say, okay, this then must be a line of symmetry because it cuts the graph or the picture perfectly in half. However, if you look, the top is not identical to the bottom. The reason being is that the top has this light, which is definitely a different shade than this light. They're not the same. Therefore, that is not a line of symmetry. Okay, let's get into some examples so you can see what a line of symmetry could look like. We have three beautiful examples right here. We'll start with this one. It's kind of like a house that has a vertical line of symmetry. If I was to cut it right here, the left side of the picture is the exact same as the right side of the picture. The way I like to look at it is if I folded this in half, it would be identical. It would cover itself perfectly. If you look at this letter E, we have a horizontal line of symmetry, horizontal meaning side to side. So if we were to fold this E perfectly in half on top of that, I would have one side identical to the other side. They would fold perfectly on top of each other. Then we have oblique line of symmetry. So when you have oblique lines of symmetry, it just means not straight up or down, not left or right. I usually call them diagonal line of symmetry. If we have this square right here, I could cut it like that. And by doing that, I could fold the thing over along that line, and I would have one side over here is identical to this side over here. They're exact same. Therefore, this is a line of symmetry. It's just an oblique line of symmetry. This one actually has more than one line of symmetry. So if you look, I also could fold this thing like this. And that would create two identical sides. It would create this side and this side, which are identical. Therefore, that is also a line of symmetry. And if I kept thinking about it, there's even more lines of symmetry when it comes to a square. So there's a line of symmetry here where I have a top half that is identical to a bottom half. I also could do a vertical line of symmetry here if I cut the graph perfectly from corner to corner, from top to bottom. I have one side, I have another side, and they're identical. So this square actually has four different lines of symmetry that we just discussed. And you're going to notice that with our pictures, sometimes there's more than one, especially when it comes to shapes like that, just regular polygons. Okay, let's look at some questions and see if we can't find some lines of symmetry. So when it comes to this glass, there's one line of symmetry. This line of symmetry is a horizontal line of symmetry. If I was to cut the glass from here all the way across, I would have one side of the glass over here, which is identical to this side of the glass over here. That means this is a line of symmetry. Because the two sides are identical. That happens to be our only line of symmetry. Sometimes people think that this is a line of symmetry because they say, well, I cut the glass in half. Yeah, but the left side's not identical to the right side. All you did was cut an object in half, but it didn't create two identical sides. Another thing that sometimes people think is that they could do an angle like this and be like, well, maybe if I perfectly cut it like that, I would create an angle that somehow is a line of symmetry. If you look, these aren't identical. Like the top part doesn't have any of the bottom of the glass, where this one has all this bottom over here. So there are no other lines of symmetry that create two identical sides. It's just that one. And we would call that a horizontal line of symmetry because it's a horizontal line. It's perfectly left-right. Beautiful. Let's look at this one. So if we wanted to find our lines of symmetry, one line of symmetry that we have is if we were to continue on with our horizontal line and go right through here, that would be a horizontal line of symmetry because the top half is identical to the bottom half. Oh, geez, sorry. This horizontal line of symmetry. There is another one. So if we took this graph and we were to cut it in half this way, it's creating two identical sides. Right? The left side is identical to the right side. That means this is a vertical line of symmetry. Perfect. And there are no other lines of symmetry on this thing. Sometimes people think you could do like a diagonal on that one. There is no diagonal that would make it so that the sides are the same. You might be able to make it equal, so there's an equal amount on each side, but they wouldn't be identical. I couldn't fold them over and make it into one thing. So it would not be an identical line of symmetry. If I look over here and I try to do lines of symmetry, I'm going to have a few on this one. So I want you to pause the video, see how many lines of symmetry you can find for this shape. Hopefully you paused and unpaused. One line of symmetry would be if we continued on thinking about horizontal lines of symmetry. I could cut this graph like that. The top is identical to the bottom. That is one line of symmetry. Another line of symmetry I could do is I could go straight up and down like that. And the left side is identical to the right side when I fold it over that blue line. So the blue line is a line of symmetry. There's two more. If I look from here to here, that is a line of symmetry. The reason being, if I folded it perfectly on that green line, the sides would be identical. It would fold over perfectly. The top half would be identical to the bottom half. This means that there's also another line of symmetry right here. Because if I folded it along that red or purple line that I just made, the right side would be identical to the left side. I'm just going to erase the other ones so that you can kind of see what the purple one would look like by itself. If you look, that creates two perfect identical sides. I have this side and I have this side. And they're identical. That means this picture actually had 4 lines of symmetry. Perfect. Hopefully you found all 4 of those. We're going to work backwards from a line of symmetry. So for instance, if we had this example right here, it says the drawing shows half of a figure. The desired dash line represents a line of symmetry for the figure. Draw a complete version of each figure. We got 2 here. It's probably, let's just talk about this one to start. So the one without the graph. If I wanted to figure out the rest of that shape, what I need to realize is that this line of symmetry means that I should have an identical image on the other side. So that means however this shape looks, if I was to kind of trace it like that, I should be able to flip that over and have it on the exact other side. So that means my line would be about that long, straight across the bottom, and then straight up. And this would be my remaining side of the shape. Because if I was to fold that over my line of symmetry, it would perfectly go on top of that shape I had above. When it's just a random drawing line like that, that's all you do. Just do your best to see if you can draw the other half of it. When it's like this, however, when we're doing a line of symmetry, it's basically the same thing as doing a reflection, which is less than 7.5. It's like having this picture and you want to reflect it about your line of symmetry. And the way we do reflections is we take points, like point B here, and we figure out how far away it is from our line of symmetry. It is approximately 2.5 away. That means this point, when it's folded or reflected to the other side, should be 2.5 away. And now I have my point B over there, or B prime is usually what we call it. So it's the exact same thing as doing a reflection, except now we're just doing it over wherever our line of symmetry is. If you look at point A wouldn't move because it's on my line of symmetry. If I look at point D, it would not move because it's on my line of symmetry. If I look at point C is also 2.5 away. That means when I draw the reflection, it should be 2.5 away. And that'll give me my other point C prime. And then what I can do is I can just complete my drawing on the other side by connecting the dots. Oh, I just erased my dot, didn't I? That one was there, and this one was here. Perfect. All we have to do is connect the dots to make our shape. I'll try to do it in black, so that means it should look like this. And you notice that we now have a shape that is being cut perfectly in half by our line of symmetry. Awesome. Lines of symmetry, basically just like reflecting from 7.5. If you forget how to do reflections, I recommend you go back to 7.5 and try it out. All right. The last thing we're going to do is we're going to do lines of symmetry on polygons. So remember a regular polygon, and that is what we're talking about here. We're talking about regular polygons. Regular means they have same side lengths and same angles. So this only works for like squares, triangles, pentagons, anything where all the side lengths are the same and all the angles are the same. Let's look at this triangle. So I know this is a regular polygon triangle because every one of these side lengths is the same length if I was to measure it. And all of these angles are the same opening. None of them get way wider or smaller. They're all identical. They happen to all be 60 degrees if you were to measure them. If I look at this triangle, they've drawn the lines of symmetry. There's 3. So there's one right here from one corner to the other side in the middle. There's one right here from one corner to the other side in the middle. And there's one right here from this corner to the other side in the middle. That has 3 lines of symmetry. If we look at a square has a few lines of symmetry as well. There's one going right through the middle of a side to the middle of the other side. There's a second one going from the middle of one side to the middle of the other side. There's a third one connecting corners. And a fourth one connecting the other corners. This square has 4 lines of symmetry. So a triangle has 3, a square has 4. How many do we guess that a pentagon would have? A pentagon being a 5-sided figure. Most people, I think, would probably guess that there's going to be 5, so we're going to test it out. If we look, all the lines of symmetry are drawn there. We start at one corner. We go straight through to the other side. That's one line of symmetry. We go to the next corner, and we go straight through to the other side. That's a line of symmetry. We go to the next corner and go straight through to the other side. That's a line of symmetry. We go to the next corner, we go straight through to the side. That's a line of symmetry. And we go to the last corner and go straight through to the side. That's a line of symmetry. And what you'll notice is I'm doing is I'm starting in the corners of the shape and connecting across to the sides on a pentagon to find all 5 lines of symmetry. Okay. This isn't a coincidence that a triangle had 3, a square had 4, a pentagon had 5. Hexagon, which is 6-sided figures, would end up having 6, and so on and so forth. The way that we could figure them out is that if you have an even number of sides, so like 4 sides, 6 sides, 8 sides, 10 sides, so on and so forth, the lines of symmetry will always be in the same spot. It'll always be by opposite vertices. That means connecting corners. And it'll also be by going from midline of opposite sides. And that'll be from mid-side to mid-side. So if we look back at our square, we'll see if this rule actually did work. The first rule was that if you have an even number of sides, you could connect the opposite corners or connect the vertices to create a line of symmetry. Well, this has 4 sides. If we connect the corners, that is one line of symmetry right there. I meant to do that in red. That is a line of symmetry right there. If we connect the other opposite corners or opposite vertices, we create another line of symmetry. The second rule was that if we connect the midpoint of each side. So if we look, we connect the midpoint of this side length to midpoint of that side, that's a line of symmetry. And if we connect midpoint of that to midpoint of that side, that's a line of symmetry. So our rules actually do work. So for polygons that have an even number of sides, that is how I could create all the lines of symmetry. For odd-sided polygons, so that's like our triangles, which had 3, our pentagon, which is 5, 7-sided figures, which is a heptagon, and so on and so forth. There's only one rule that you have to follow to find lines of symmetry, and that rule is go from vertice to mid of opposite side. That's from corner to mid side. And if we look, that's exactly what we did on our triangle. To find all of our lines of symmetry, we went from corner or vertice to the middle of the side length across from it. We went from corner to middle of side length across from it. We went from corner to middle of lines from the side across from it to create all 3 lines of symmetry. Perfect. Our last rule that we have for polygons is that a regular polygon, and it has to be regular, meaning all the sides are the same length, will have the same number of lines of symmetry as it has sides. So if I look at this, it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. That means it's going to have 10 lines of symmetry because all those side lengths are the same length. And I know that a regular polygon or a shape that has all sides the same will have the same number of lines of symmetry. If I wanted to draw those lines of symmetry, because it's an even-sided figure, even number, then what I need to do is connect the corners like this. So if I connect corners, that would give me a line of symmetry. That's 1, that's 2, that's 3, that's 4, that's 5. So that's from connecting corners. And then I need to connect middle of side lengths to middle of side lengths. That's my 6th line of symmetry right there. My 7th line of symmetry right there. My 8th line of symmetry right there. My 9th line of symmetry right there. And my 10th line of symmetry right there. So I get my lines of symmetry by connecting corners or connecting middle of the side lengths. And that's because It was an even number of sides. For this one over here, we actually have an odd number of sides. If we were to count them, 1, 2, 3, 4, 5, 6, 7. There's 7 sides. The way that we find our 7 lines of symmetry is by going from middle. Going from one corner straight down to the middle of the side. That's 1 there. Start at the corner, go to the middle. That's 2. Start at the corner, go across to the middle. That's 3. Start at the corner, go across to the middle. That's 4. Start at the corner, go across to the middle. That's 5. Start at the corner, go to the middle. That's 6. Start at the corner, go to the middle. That's 7 lines of symmetry. Perfect. You are now, hopefully, the master